have questions. Okay, so just a heads up for all of my seniors, I need you guys to check your emails. I just sent you a link to the final. So all of my seniors who are in the class, check your email. And if you want to, you do not have to be here for the remainder of the time. So you logged in, I got you for attendance. So seniors, go ahead and check your email. I sent you a link to your final. You guys are going to log out of Zoom and work on that. It is due Thursday by 10:30 a.m. So if you're a senior, go ahead, check your email, and get working on your final. Okay, seniors only. Yes, seniors, there is advisory tomorrow. So make sure you guys go to advisory tomorrow. And good luck on your final, guys. And you have until Thursday morning to get that done. But I'm sure the vast majority of you guys will get it done today. Yep, have a great day. All right, everybody else, let's go ahead and go over this warm-up. And as always, as I'm going over it, if you guys have questions, let me know, and we'll go over that. All right. So the seniors are good to go. And now it's just you. All right, so let's take a look, guys. So, sorry, I got to unfreeze this. So we got two different types of problems. The first problem is kind of what we did last class, and the area problem is what we did a couple of classes ago, okay? So we're going to go ahead here and take a look at both of these, and if you guys have questions, please ask right away so we don't go into the new stuff with you still confused about the old stuff, okay? So, yeah, let's take a look. So, again, let me know if you have questions. So this first one, this is a prism. So we talked about bashing. We're really going to talk more about bashing today. We know because it has a flat base, and then it extends out to the same flat base on the backside. So what we're going to do here is we're going to say, hey, the volume here is going to equal, so oops, pen's not working. Volume equals area of the base times the height. So the capital B is the area of the base. Okay, so we replace B with the equation for the area of the base. So in this case, our volume is going to equal, this is a triangle. So the area for a triangle is 1/2 base times height. Now, as you can see, this might get confusing because now there's two H's here. That mean two different things. So the height here means it's the height of the triangle, right? Whereas the height here means it's the distance between the bases. So that is kind of confusing. So just make sure, that's why we're practicing these things, and make sure that you guys keep an eye out for that and don't get confused by that, okay? All right, so we're gonna go ahead and fill in all of our information. Now, don't worry about base and height of the triangle. It can go in any order you want because it's multiplication. So if you're like, oh, I don't know if it's the 6 or 8, it's not a big deal. It's right, you just pick them, put them in there. So we're gonna get 1/2 and then 8 and then 6 and then times that by the distance between the bases, which is 10. Now notice how we have 3 lengths multiplied, right? So our units is going to be cubed, right? It's going to be the third dimension. I just go ahead and grab my calculator here. So what do I have? I can even do the fractions on these fancy calculators. Ooh, so fancy. 1/2, 8 times 6 times 10. And we got our volume equals 240 centimeters cubed, right? So don't forget the units on that as well. Okay, does anybody have questions about this, right? That's kind of what we worked on last class. Any questions about that? Any concerns? What do you guys think? You guys are good? All right. All right, let's take a look at this next one. So I think we did a problem very similar to this, but I just want to make sure you guys can do this. If you can do this, you can do any shape because it has 3 different shapes, right? So we have 1 shape, 2 shape, 3 shape. So if we're going to find the total area here, we're going to add together all 3 of these. I'm sorry you lost track of time. Okay, so let's start with the first one. So the first one is a half circle. So we're going to find the area of a half circle. So that's going to be 1/2 the area of a circle. So the first thing we need to do, right, there's only one thing when it comes to finding area of a circle, and that's the radius. So how are we going to do this? Well, we're going to have to look at this. So this is 5. It looks like this is a square. So this is going to be 5, and this is going to be 5. So if this distance right here is 5, that's the diameter, right? So the diameter isn't the radius, right? The radius is half the diameter. So when I go to write this, I'm going to have 1/2 pi, and then it's going to be 5/2, right? Or half the diameter. Now, again, we don't want decimals, right? We don't want decimals. We don't want to round. So it's really important that when we're doing this, right, we avoid decimals. So when I do this, I'm just going to go say, hey, squared. 5 times 5 is 25, and 2 times 2 is 4, right? So 5/2 squared is just 5 times 5 and 2 times 2. So I get 25 over 4. And then 1/2 times this, well, you just multiply the top by 1 and the bottom by 2. So I get my area of 1/2 a circle is 25/8 pi and then centimeters squared. And the reason why I do this is my exact answer. No rounding whatsoever. Now you probably can write 25/8 as a decimal, right? That's going to be fine because it's a rational, right? It can be written as a decimal. But pi is irrational. That goes on forever. And so if we got rid of the pi or multiply that out, we'd have to round. So I'm not going to do that. And if you don't write it as exact, right? When we go to write these all out, your answer is going to be off a little bit. So for our second shape, we have a square. So we're going to have the area of a square, right, is length times width. And it's a square, so they're the same, right? So it's going to be 5 times 5, or 5 squared, right? That's why they call it a square, right? So 5 squared is 25, and then centimeters squared. Okay. And again, if you guys have questions, if I do something that's weird, go ahead and let me know. Okay. And then my third shape, I'm going to have a triangle. So the area of a triangle equals 1/2 base times height. So I'm going to have 1/2 7 times 5. Okay, so 7 times 5 is 35. So you can just write this as 35/2 centimeters squared. Again, yes, we totally could have written this as a decimal, but I'm just going to get into the practice of not writing it as a decimal, because as problems get more and more complicated, it's going to be more and more important that we get exact answers without weird decimals, okay? The decimals for fractions that are divided by even numbers tend to be nice. It's the ones that are divided by odd numbers that aren't very nice. Okay. Let's go ahead. So now, next thing we want to do is we want to find our area total. And that's going to be area 1 plus area 2 plus area 3. So I'm just going to go ahead and do that all at once on my calculator. So I'm going to have 25/8 pi plus 25 plus 35/2. And I add those all together, and I get that my area total is approximately 52.32 centimeters squared. And notice the unit difference, right? So I'm talking about an area, so I'm going to have centimeters squared versus centimeters cubed for volume. All right, so that's the story there. So that's my answer, right? So my total is going to be approximately 52.32. And again, we use exact answers before we get to this so that we don't have a rounding error. Okay, so so that was a little bit of review. Does anybody have questions about that? How are we doing? You guys doing okay? Does this make sense, or do people have questions? Okay, thank you for the feedback. I appreciate it. Okay. I just don't want to go on and teach new stuff if you guys are like still stuck on the old stuff, right? That doesn't make sense. All right. Well, I'm I'm not hearing anybody saying that they're lost, so we're gonna go ahead and take a look at the new stuff. So the new stuff is we're gonna be looking at 2 sections today. Yeah, so I would not recommend working on missing work during class because you're gonna miss everything we're doing. And also, warm-ups have a tendency to show up on tests. So that's why I do them. So if we're not doing the warm-ups, you're putting yourself at a disadvantage. So volume of pyramids. So we're going to do volumes of pyramids and cones. Okay. So we're going to do volume of pyramid and cones. So the first thing that we're going to do is we're going to do a little art lesson on how to draw these, right? So we'll start with pyramids. So the easiest way that I've found to draw a pyramid is to start with a triangle. Okay, that's going to be one of our sides. And then, so this isn't going to be like a prism. So a prism, you start with a base, and then that base goes all the way through. So in a pyramid, you're going to have a base and then it goes to a point. So in this one, we're just going to go like that, but then we're just going to connect it to this point. And then to make it look 3D, we're going to do the same thing, but with a dashed line in the back, like that. Okay, so that's the easiest way. Now, this type of pyramid, this is called a rectangular pyramid. Rectangular pyramid. Okay, and the reason why it's called a rectangular pyramid, if you can guess, is that the base is a rectangle. Okay, so you could take any polygon and make it into a pyramid. You could have square pyramids, you can have triangular pyramids, you can have pentagonal pyramids. What they have in common is that the sides are all going to be triangles, and it starts from a base and ends at a point. And this point at the top is called the vertex. Okay, so that point is called the vertex. I don't think you're going to fail. I don't think that's going to happen. Okay. So we have the vertex up here. Okay, and that's just a basic pyramid. Okay, so the base here is a rectangle, and I'm going to have a vertex up here. So the next we want to do a cone. Now a cone is going to start out kind of the same, but we're going to draw a triangle without the bottom connected. Okay, so it's just going to kind of look like an upside down V. Okay, you can think of it that way too. Okay, and then instead of connecting the bases with a straight, we're going to do a semicircle. And then we're going to draw the other part of the semicircle with a dashed line in the back. And it kind of gives it a 3D shape. Now, with a cone, we don't name it by its base like a pyramid does, because in a cone, the base is always going to be a circle. Okay, but what these two have in common and why we're grouping these together today is that the top here is also called the vertex. Okay, so we have a rectangular pyramid and a cone. Okay, and they both have a vertex. And the vertex is why I have such a silly reason to name these things. And this is what we're going to talk about today, is because with prisms and cylinders, you guys heard me say bash, right? And a lot of you are like, Kref, that's overly violent, right? Like I was like, these are objects that you would bash someone to death with. And people were like, what? Right? Do you guys remember that? Okay, so prisms and cylinders are items that we bash people with. Now, these items wouldn't be bashing items. These items would be stabbing items, right? This little point up here, right, that would puncture and stab into somebody, okay? Now, again, I know this is awfully violent, but the reason why I'm doing this analogy is that you guys have to remember the differences between these equations, and you guys don't have calculus. And to get this from calculus, we would need the integral. We would need to integrate the area and then go from there. Now, since we don't have that, then I have to come up with something really weird for you guys to remember. Because the weirder it is, the more likely you guys are to remember it. So again, stab. These two have points. You would stab someone with this shape, right? You wouldn't bash them, you would stab them, right? It would penetrate, it would go right in, okay? So, to remember this, we're going to need to know a phrase. And this is the phrase we're going to remember when we see these shapes. We're going to say, if you stab someone, okay, if you stab someone, they will lose 1/3 of their blood. Okay, now, I agree that if an administrator is walking behind you right now and they see you writing this down, that might be troublesome, okay? But you can just explain to them that Mr. Kraft is trying to get you guys to remember the equation for volume of a pyramid and a cone. So the way that we're going to remember it, and right, it's a little weird writing this down, right? But if you stab someone, they will lose 1/3 of their blood, okay? So before you guys go and start thinking I'm crazy, okay, this is a really good way to remember volume, okay? So let's make a table of this. Let's make a table of this. So the table is going to look like this. At the top, let's just go volume. And then we're going to have shapes that bash. Oops. We're going to have shapes that bash, and we're going to have shapes that stab. Okay, so we're going to have, so in our volume chart, we're going to have shapes that bash and shapes that stab. Now, again, you guys might think like, crap, there's got to be another way, right? Like, why are you making this so violent? Well, I used to have this cool way of like doing this like science experiment to show you that the volumes and how they're related, but all of that gear is in storage, and I don't even know where it's in storage. It's in a warehouse somewhere in town, and so I can't do that. So we're gonna have to fall back on maybe a little violent, you know, analogy. So shapes that bash. Well, one of the shapes that bash, if we draw a rectangle, right, we can make this into a prism. Okay, that's a shape that would bash, right? You would, right, you would just hit them. If they're flat surfaces, it wouldn't penetrate. Now, some people always point out, well, like, well, wouldn't you cut someone with the edges? Sure, right? But you can cut yourself on a lot of things, right? So this is a bash shape. Okay, another thing that is a bash shape is a cylinder. Okay, you'll never look at a can of tuna the same way. Okay, so we got bash. Okay, these shapes are bashing. Stabbing shapes, though, those are our two new ones, right? They have a sharp vertex, right? They go to a point. So if you hit someone with that shape, it would penetrate. It would stab them. Okay, so that is a pyramid, or we might have a cone. Okay, so we got bash shapes, we got stabby shapes. How are we doing so far, guys? Just remember, for it to be a stabby shape, oh, I love the thumbs up, right? So for it to be a stabby shape, it's got to have a vertex, right? It's got to, right? If it hits someone, it would penetrate, okay? So bash is volume equals area of the base times the height. Now, notice how the word bash looks a lot like area of the base times the height. Okay, right? Bash. Volume equals bash. Area of the base times the height. Okay? Whereas stab, what happens if you stab someone? Well, if you stab someone, they lose 1/3 of their blood. Okay? So, boom, there you go. If you stab someone, they will lose 1/3 of their blood. Bam. That's how you remember stabby shapes are 1/3 the area of the base times the height. Okay? Now, I used to do this really cool experiment in class. I'm really sorry that we can't do that just because I just don't have the shapes. They're in storage somewhere, wherever that is. All right. So we got bash shapes, we got stab shapes. If you guys have this down, everything is going to be good. So you look at the shape and you say, is it a stab or bash shape? That's the volume. Okay. So make sure this is loud and proud in your notes because this is going to be a big part of your final come June 15th. Okay, so June 15th, this is going to be a big, I think June 15th. What period is this? This is 4th period, right? Yeah, June 15th, this is going to be a big part of your final. Okay, so being able to find volumes. So make sure this is nice, loud, and big in your notes. Okay. So what we're going to do for the rest of class is we're going to practice using these and make sure we know how to use them, what it looks like, and how to do a little bit of algebra with them, right? Because sometimes we don't have what we want and we need to be able to solve for it, okay? All right, so stab and bash. Don't be bashful about stabbing. That's what they say. All right, let's do an example. Okay, so we're gonna find the volume. All right, so to do this, I'm going to draw a triangular pyramid. Now, a triangular pyramid is a pyramid with a triangular base. So let me give you a little drawing tips on how to do this. So first, I just draw two sides at a 90-degree angle. And then the hypotenuse, I do a dashed line. Okay, so I drew two sides at a 90-degree angle. And then I drew the hypotenuse on a dashed line. Okay. Then from the 90-degree angle, I'm going to go straight up. And where I end is my vertex. And I'm going to connect here and here. And I have a three-dimensional triangular pyramid. Okay. So if we label this, I could call this 4 meters, I could call this 6 meters, and I can call the height 9 meters. Okay, so there's just a simple little problem there. And what we're going to do is we're going to find the volume of this shape. Okay, so the first thing we have to identify is this a bash or a stab? Well, judging from the vertex right here, right? This would be our vertex. This would be a stab. So volume is going to equal 1/3 times the area of the base times the height. Yeah, stab them. I see how you guys work. So I'm going to get volume equals 1/3. Now, what shape is the base? The base is right? If I highlight this in red, not because it's losing 1/3 of its blood. Really, this is getting kind of dark craft. So that's a triangle. So when I go to type this in, I'm going to have the area of a triangle, just like I would do for the volume of a prism. Okay, so the only difference here is because I'm stabbing them, I'm losing 1/3 of my blood. So I'm going to get volume equals 1/3, then 1/2. And again, don't worry about which one's the base, which one's the height. All that matters is that they're perpendicular to each other. So I can have 4 and 6, and then the height of the pyramid is 9. Okay? And at this point, we can just do this all at once. So really, I think this is just 2 times 6 times 3, but that's okay. I will do it the long way. 1/3 times 1/2 times 4 times 6 times 9. Right, so I just typed it in exactly how I have it written. And then I get 36. So the volume would equal 36. And then what are my units? Meters. So 36 meters cubed. Like that. So 36 meters cubed. Where did I get the 1/2? That's the area of a triangle. 1/2 base times height is the area of a triangle. Right, and we're going to take a look here in a little bit at different problems, right? So if the base was a rectangle, then it would just be length times width. And if the base was a circle, right, it'd be pi r squared. Okay, so it's just depending on what that base is. And I'm glad that you asked that question. Thank you so much. All right, so again, the steps are the same as doing it with the prism. The only thing difference now is that there's a 1/3 in there, and that's it. And the 1/3 comes from an integral from calculus, and you guys aren't there yet. So all we're gonna think again is it loses 1/3 of its blood. Neat. Or a less violent might be like if I was packaging Cheez Whiz, it holds 1/3 less Cheez Whiz. Okay, than a prism of the same base and the same height. Okay, so some people might appreciate a less violent example of that, but who would want less Cheez Whiz? You know what I'm saying? Like, pyramids are lame. Okay? All right. Then, let's take a look at a different one. I'm actually going to have you guys... No, I'm going to do this one with you. Okay. And then I'll have you guys do the rest on your own. So this is example 2. So we're going to use volume to find missing parts. So an example of this in the real world would be like if you have a hole in the ground and you don't know how deep it is, okay? But you know that the hole, you know the dimensions, right? You know, like the hole is like a foot by 2 feet, okay? But what you can do if you have a way of measuring water, like how much water, you can fill the hole with water and you can say, okay, there's this much water in it, so it's got to be this deep. Okay, so that is a practical application of this, something that they do. So we're going to use volume to find missing parts. So we're going to use a triangular pyramid again for this. So I'm going to go ahead and use... I have one here and one here. I'm going to make this dashed. So, and then I'm going to come straight up and come down. And I'm going to call this 3 feet by 4 feet. Except this time, we don't know the height. So the height is going to be unknown. And we know that the volume is 14 cubic feet. Okay. English is weird because when we say cubic feet, right, we put the cubic before the feet, even though we write the 3 after the feet, right? So this would read as 14 feet cubed, but when we say it, we say 14 cubic feet. So English is weird. Blame that on English, not on math. Okay, not on the math, on the English. All right. So let's keep going along here. So we're going to solve this just like we're going to solve for V. We're going to figure out, is this a stabby or a bashy, right? And it is definitely a stabby. So we get volume equals 1/3 area of the base times the height. Oh man, my hand is cramping up seriously right now. This is not good. Sorry, I'm having some finger pains right now. What shape is the base? The base is a triangle. So the area of a triangle is 1/2 base times height, right? So this is the area for a triangle, 1/2 base times height, and then times the height of the pyramid. So what we're going to do is we're going to fill in with our missing information. So velocity equals 13 feet, 14. I swear I can read. So equal, okay, let's start over. 14, right? feet cubed. And then that equals 1/3. And then I have 1/2. And then I have 3 times 4. And then I don't know the height. Okay, so all I did here is I replaced my v with the 14 that I knew. I replaced the base and height of the triangle with the numbers on the base of the triangle. And then I don't know the height of the pyramid, so I'm leaving that as h. So at this point, what we need to do is we need to solve for h. Okay. So to do that, there's actually a really quick and easy way to do this. Notice how this is all multiplication on the right. It's 1/3 times 1/2 times 3 times 4. Well, what's the opposite of multiplication? The opposite of multiplication, right, is division. So all we're going to do is we're going to divide, okay? So we can just divide everything here, and we get 14 divided by 1/3 times 1/2 times 3 times 4, and that equals h. Okay, so if this is all multiplication, the 14, the volume equals 14 feet cubed. So the volume, I replace volume with 14. So we know the volume, we don't know the height. That's where the 14 came from. Does that help out? Okay. Thank you for asking. I appreciate that. Yeah. So then it's all multiplication. So the opposite of multiplication is division. So we divide both sides by this. And so I just take my calculator and we get 14 divided by, I can even do fancy fractions. Look at this, 1/3 times 1/2 times 3 times 4, and I get 7. So then I add units to this, which is feet. So the height is 7 feet tall. Okay, and if you're keeping track of how many people I murdered, that is 3.5 people. I thought that was a funny joke, but maybe it wasn't. All right, so, right, because we're stabbing people, get it, right? Feet, as in like humans have 2 feet. So if there were 7 feet, that means there would be, right, 3.5 people. All right, good talk. Anybody have questions? All right, so you guys are going to be ready to try some on your own? Mm-hmm. Ooh, try some on your own, you will. Let's try it. Okay, so let's do, so this is my third example. This is going to be try on your own. So find volume. And then the shape for this one is going to be, let's do a cone. Let's do a height of 4.5 meters and a radius of 2.2 meters. Okay, so I'm going to give you guys a little timer for this. I think 2 minutes and 30 seconds will be ample amount of time. All right. So let's talk about this and see how it went and see where we're going. So the first thing, it's bash or stab. So this is a stab. So volume is going to equal 1/3 area of the base times the height. Okay. It's not a pyramid. It's a cone, right? So that means that the base is a circle. So the area of a circle is pi r squared. Sorry, my handwriting is even more bad today because my hand's cramping, so I'm not holding my pen in a very natural way. So let's take a look. We have our height. We have our radius. We're good to go. So I'm just going to plug everything in. So I have V equals 1/3. And then I have pi. And then my radius is 2.2 squared. And then times my height. Okay. So I grab my calculator. Now, a pro tip here, when we're multiplying, one way to get an exact answer is don't include the pi. So you could totally just do, since it's all multiplication, just do the numbers. What I mean by this is I can go 1/3 and then times 2.2 squared. Notice how I'm not doing the pi, and then times 4.5. And then what I get is 7.26. So I can say my volume equals exactly 7.26 pi, and then what were my units? Meters cubed. Okay, so this is a neat little nifty trick so that you guys don't have to round and get that. And that's going to be really important when we get to composite shapes, which we're going to do next. Okay, now approximately all I have to do then is multiply that by pi, and I get, this is approximately 22.81 meters cubed. Okay, like that. Okay, does anybody have questions about that? Do you guys see how I got my exact answer by just leaving pi out of it? Yeah. Yeah. Now you can't always do that, right? That only works if your number is a rational number, right? If you get an unrational number, then you're gonna have to do the rounding. Big ideas will either ask you to round it, and it will tell you what decimal to round it. If it doesn't ask you to round, then it's asking for the exact answer. So I've seen big ideas do a lot of this, but when we're going to do composite shapes, you're going to want the exact because you don't want to round each time that you're finding a basic part. Okay? Speaking of which, our last problem that we're going to do today is example 4. And you guys are going to find the volume. Oh, no, sorry. Find the total volume. And what we're going to have here is we're going to have a cylinder. And then we're going to have a cone on top of it. And the cone has the same base as the cylinder. So the cone has the same base as the cylinder. Okay, you can think of it, if you want to have a little more excitement in your life, you can think of it as a, what do they call those? A firework, and how much gunpowder can we put in this? Okay, so I'm going to give you the same amount of time, and then we'll go over this. So find the total volume. Sorry, we're running out of class time, so I can't give you more time. So let's get a shot of this. Can you find the volume of both shapes, add them together to get the total volume? All right, I don't have a ton of time left, so we're going to break this up. There's two shapes. The first shape is a cone, and a cone is pointy. So that's going to be 1/3 area of the base times the height. Now for both of these, the base is going to be a circle. Okay, so for this first one, I'm going to have 1/3 pi times 6 squared times, now we got to be careful with the cone's on top, so I'm not going to use 5 as my height, I'm going to use 4. Okay, so I want this to be an exact answer. I don't want a rounded answer. So I'm just going to do 1/3 6 squared times 4. So I get 48. So I get the volume of the cone equals 48 pi and then meters cubed. Okay, that is an exact answer. So I always want to go for an exact answer if we can. If you can't, then you can't. Okay. Our second shape is a cylinder. Okay, so it's a cylinder, and it's a bash. So it's just volume equals area of the base times the height. And the base here is a circle. So it's going to be pi times 6 squared. And then the bottom height is 5. So I'm just going to go 6 squared times 5. And I get 180. So the volume of the cylinder is 180 pi meters cubed. Okay, so I got my volume of my cone, the volume of my cylinder. So the volume total is going to equal, right, 48 pi plus 180 pi. And if I add those together, that's 228 pi meters cubed. So that is my exact answer. Okay, that's my exact answer. Now, if you didn't get an exact answer, I would get 228 times pi. Now my calculator is like, you want the exact answer, and I say, no, I don't. And I say that's about 716.28 meters cubed. All right. So guys, sorry, we're at the end of class. Get out of here. Oh no, we're not. It's 2:56. Oh my gosh, guys. Does anybody have any questions about this? Don't leave just quite yet. Does anybody have questions about this? Okay, so our schedule is going to change just a little bit now in these last couple of weeks because we didn't have school yesterday. So that means Thursday, the next time I see you, is going to be a work day, and then Friday is going to be a new material day. So Tuesdays and Fridays will be our new material, and Mondays and Thursdays will be our work days, okay? So I know it is a little bit early, but why not? Guys, if you want to pack up and close up shop, you can. I will post this video on YouTube, and on Thursday we will we'll get going, okay? So bye everybody, take care, have a great day, have a great Wednesday, and don't stab anybody.